Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 5 Linear Programming. Topic Introduction, Definition of related terminology such as constraints, objective function, optimization, mathematical formulation of LP problems, graphical method of solution of problems in two variables, feasible and infeasible reasons, feasible and infeasible solutions, optimum feasible solutions up to 3 non-trivial constraints. Exercise 12.1. Linear programming. What is linear programming? Linear programming is a mathematical technique for finding an optimum value of a function called objective function, consisting of several variables subject to a set of constraints expressed as equations or inequalities. Linear programming problem haibasi mathematical technique amani angkagi oiba technique amani. Function amagi khwaidigi pikpa natraga khwaidigi chawba value puthoknanabagi technique amani. Madubu function dubu objective function kawi masida several variables yaugani. Adugumba singado set of constraints limitation ama laigani expressed as equations or inequalities. Equations sing the natraga inequalities sing the phongdokpa constraints singi set ama zumhanba oigadabani. A linear programming problem has the following parts. Linear programming problem asigi makhagi parts sing asi lei. Ahanbada a linear objective function. It is a mathematical statement of what management wishes to achieve. Linear objective function haibasidi management aduna phange haina khalliba angkagi oiba statement amani. Decision variables. The decision variables are the quantities to be determined in the problem. Decision variables sing haibasidi quantities singni makoisi problem aduda puthokadaba yamna maru oiba quantities singni. Constraints. Constraints are the physical limitations on the use of manpower, machinery, raw materials, etc. Constraints sing asidi sijinagadaba manpower gi mahaki limitation, machinery ki limitation, raw materials singi limitation, daba tabaya daba restrictions sing adubuni. The constraints are expressed as linear inequalities in terms of decision variables. Constraints sing asidi decision variables singi linear inequalities sing da phongdo a. Non-negative restrictions. In physical 1, there is no validity of negative values of decision variables. Decision variables sing as a physical 1 the negative values obeyade fractional number obeyade madugi restrictions sing adobani. Formulation of linear programming problems. LP amagi equation semba. Ahanbada identify the decision variables. Decision variables to ahanbada masak khangdu o. Identify the decision variables and assign x and y to them. Decision variables in the masak khangdo o aduga makoi singado x amasung y haina thonjello. These decision variables are those quantities whose values are to be determined in the problem. Adugumba variables sing asidi decision variables sing asidi wahangda puthokpa darkar oiba quantity sing aduni. Identification of objective function. Objective function masak khangdokpa. Identify the objective function and express them as linear equation or inequation in terms of the decision variables. Objective function masak khangdu makoi singado linear equation natraga linear inequation da decision variables sing the phongdu. It might take the form of maximizing problem profits or minimizing costs. Adugumba objective function ado profit yamna chawna phangnabagi natraga paisa achangman yamda nanabagi oibasu yai. Identification of constraints. Constraints sing masak khangdokpa. Identify on constraints and express them as linear equations or inequations. Inequation haibadi inequality buni in terms of x and y. constraint sing du masak khang du u makoi sing ado x amasung y decision variable sing equation linear equation natraga linear inequality sing ado phung du u non-negative restrictions negative obiyadaba restrictions put non-negative restrictions on the decision variables sing adu da negative obiyadabigi restriction thamu hariba sing ase part se ahan bada identify the decision variables mathang da identification of the objective function mathang da identification of constraints mathang da non-negative restriction hariba part sing ase linear programming problem amagi equation semba haibadi formulation tawbada changba part chine reason the common reason determined by all the constraints including non-negative constraints of a LPP is called feasible reason linear programming problem amagi constraint pumnamak non-negative constraints sing yauraga lepa common reason adubu feasible reason kawi feasible solution points on the feasible reason and all the boundary represent feasible solutions of the constraints boundary feasible reason gi dalaiba point pumnamak boundary points sing su yauraga maduna feasible solutions of the constraints singi feasible solution kawi optimum feasible solution any point in the feasible reason that gives the optimum value of the objective function is called an optimum solution feasible reason ki any point amana objective function ki optimum value pirabadi adugumba point adubu an optimum solution kawi theorem 1 let R be the feasible reason for a LPP and let Z equal to ax plus by be the objective function linear programming problem amagi R sina feasible reason to khangnarasi aduga Z haibadina ax plus by asuna linear sina objective function ohelasi when Z has an optimum value where the variables x and y are subject to constraints described by linear inequalities this optimum value must occur at a corner point of the feasible reason adugumba Z asina optimum value piba matamda x amasung y hariba linear in constraint sumut chumhanba variable se masi corner point da feasible reason ki corner point da thokani haiba Z pu optimum value piba x amasung y ki value da feasible reason ki corner point da soidana thokani haiba theorem 2 if R is bounded when then the objective function Z has both a maximum and a minimum value on R each of these occurs at a corner point of R haibasi bounded oraba objective function asigi maximum amasung minimum value da R gi result animak leirabadi adugumba each of these occurs adugum value ani se occurs at a corner point of R feasible reason adugi corner point da thokani corner point method the method comprises the steps method asida makhagi steps sing asi changi ahanbada find the feasible reason of the LPP and determine its corner points either by inspection or by solving the two equations of the lines intersecting at that point ahanbada feasible reason putu LPP adugi corner point singa do putu madu inspection na putokpa ngamagana ngame ngamdragana line anidubu represent toriba equation anido solve toraga phangani anisubada evaluate the objective function z equal to ax plus by at its corner point khudingmakta objective function gi value putho ani let capital M and small m denote the largest and smallest values of these points adugumba points sing adu the z ki phangiba value sing adu gi manungdagi khwaidagi chawbudone m ni khwaidagi pikpudone m oiraba number 1 da 3 gi 1 da when the feasible reason is bounded feasible reason the bounded oirabadi m capital M and small m are the maximum and minimum values of z when the feasible reason is unbounded oiragadi we have capital M is the maximum value of z if the open half plane determined by ax plus by greater than m sigi mc akhona khwaidagi chawba value duni z ki masidagi chawba ax plus by greater than m have inequality asiga half plane asina has no point in common with the feasible region. Sigi inequality ki graph asiga hana gi feasible region siga common point laitrabadi z habsina max m sina z ki maximum value oiganeba. Common region laitrabadi no point in common with the feasible region haiba. Haiba inequality feasible region ka sigi half plane asiga common region laitrabadi z ki maximum value m asina maximum value of z atum oiraneba. Common region lairabadi otherwise habidi common region lairabadi z has no maximum value z ki maximum value laite. Similarly, small m is the minimum value of z if the open half plane determined by ax plus by less than a small m has no point in common with the feasible region. Z ki small value m asina z ki minimum value oigani karigumba inequality asiga half plane asiga feasible region asiga common region laitrabadi small m asina z ki minimum value oigani common region lairabadi otherwise habidi common region lairabadi z has no minimum value z ki minimum value laite. Linear programming exercise 12.1. Solve the linear programming problems graphically. Maximize z equal to thrice x plus 4y subject to the constraints x plus y less than or equal to 4, x greater than equal to 0, y greater than equal to 0. The graphs of the equations ahanba inequality asigi corresponding equation x plus y equal to 4 ni, ani subagina x equal to 0 ni, ahum subagina y equal to 0 ni are the lines ahanbagi sidi maming anauba ama tholani ab x equal to 0 ki graph t y axis ni, y equal to 0 ki graph t x axis respectively. The shaded region OAB haribashina line adubani 4 laga 40 da a kaure mafam asi y axis puna 4 laga 0 origin dagi y axis ta 4 ka kara leba point b ni sigi coordinate 0 point line asibu represent tawriba line asi graph asibu represent tawriba equation adi x plus y equal to 4 masi ahangwa jaga sidara natraga this or this mafam ama ane ahum mari manga taruk lay khara ahangba amada equation si isingani mathangda x equal to 0 hairagadi y axis puni y axis ki jaga left right mafam taruk si gi ahangba jaga amada equation x equal to 0 igani y equal to 0 hairagadi x axis puni masidi ahangba this or here ahangba jaga taruk mapung oin taruk laidiba se masigi jaga ahangba mada equation si igani. Feasible region tisina oribagi maramdi x inequality asiga half plane de line asigi below asini below the leba point khuding magna inequality asiba chumali haibadi origin gi coordinates sinjalase 0 0 0 tare 0 na 40 pt chumi makhatang masaru oire x greater than equal to 0 di y axis amasu mahaki right ward ni y greater than equal to 0 ga half plane di x axis amasu mahaki upward shini the common region to the triangle OAB theory. The shaded region OAB with vertices origin is generally 0 0 layer, A 4 0 layer, and B 0 4 layer is the feasible region. Feasible region the feasible solution theory. At O the value of z is 3 into 0 plus 4 into 0 0. At A the value of z is also 3 into 4 plus 4 into 0 that is 12. At B the value of z is 3 into 0 plus 4 into 4 that is 16. Value marisi point marisi ki value ahum si phange ahum si ki quite maximize ni quite saw 0 12 16 ni region asi feasible region asi so bounded ni sai corner point method to pansi thus maximum z is 16. It is only when x is 0 y is 4. Sina magi solution. Number 2. Solve the linear programming problems graphically. Minimize z equal to minus thrice x plus 4y subject to these inequalities mari. Graph exit the graphs of the corresponding equations corresponding to masi I divide to intercept form style and thame. Sigi corresponding equation equal to p raga pange 12 na yelaga intercept form da thame. x equals 0, y equals 0 are the lines ahanbagini AB ani subagini CD. X equals 0 di maming leiba line ni y axis na mahut kogani atop maming ama tholaro y equals 0 di x axis respectively is in this picture. Picture sida AB haribasi ma ki makhat I thole x axis ki or positive ta I chalo point A kaure madu I0 ni magi coordinate aduga y gi makhada phole origin gi upward phol ka khalo point B tholo ma ki coordinate 0 point ani si samjanaba lai asi singani line asi ga ahangba jaga amada line asi bu represent of equation x plus twice y equal to I2 this or here or this jaga amada irani asumna mathangi di x by 4 plus y by 6 x 4 chatlo aduga 6 ka khatlo point c amasung d tholo c gi na 4 0 orani d gi na 0 6 on ani ji samjanaba lai asini ma ki corresponding equation this the laire so any jaga ma ga naknaba jaga amada khoni igani asumna x equal to 0 di y axis ni y equal to 0 di x axis ni inequality singa sigidi ahan bagi si line ab asigi makha asini ani subagi asisu line cd asigi makha asini x greater than equal to 0 di y axis amasuma ki right water labor point sini y greater than equal to 0 di x axis amasuma ki up water labor point sini hojik shaded toriba region asidi common region ni inequality mari mapu chumanba jaga ni boundary point su yauna. The feasible region is the shaded region OCPB with vertices ogidi 0 0 ni c gidi 4 0 ni p gidi line ani sibu represent toriba equation ani se solve toraga phangakoni 2 3 usum b gidi graph e par yaw kore 0 4 ni respectively si oire. At O, the value of above z is minus 3 into 0 plus 4 into 0 0 phange. At C, the value of z is minus 12. At P, the value of z is 6. At B, the value of z is 16. Value point mari sigi value mari phange. Mari sida z ki minimize z and the quite people minimum z sida kanana ore minus 12 na. Thus minimum z is minus 12 when x is 4 and y is 0. Question number 3. Sisu maximization problem ni mamang da khot ki do sindu ga manai the graphs of the equation this na 15 yalaga si phange ani subagi na si phange 10 yalaga si phange matangi equation the x equal to 0 and y equal to 0 are the lines ahan bana a b c d y axis x axis respectively is in this picture c and c. The feasible region is the shaded region OCPB with vertices O gidi 0 0 laire origin gidi C gidi 2 0 laire P gidi line ani sibu represent by equation ani se gi solve toraga phanga value ni 20 by 19 45 by 19 and B is the graph e ko yaw kre mark 0 3 ni. At O, the value of above Z is 5 into 0 plus 3 into 0 0 phange. At C, the value of Z is 10. At P, the value of Z is 12 whole 7 by 19 phangani. At B, the value of Z is 9. Value mayam sing sigi manung dagi kono poto kadari basi maximize ni close figure ni. Maximize Z oraga di ahan by step P the ore. Thus maximize Z is 235 by 19 when X is 20 by 19 and Y is 45 by 19. Question number 4. Minimize ni problem mathuk to ko ki basing duga mane ahan bada graph ex graph ahan bagi corresponding equation ni silerani ani suba inequality ki corresponding equation ni silerani makoi singsi 3 na 2 na matang chini yalaga intercept formula thame x equal to 0 and y equal to 0 are the lines ahan bana a b c d y axis x axis respectively is in this picture 3 1 haraga di 3 salaga 1 ka kat pasine a b ore aduga 2 2 haraga di 2 salaga 2 ka kat pasine c d kaure. Hariba line singa si feasible region is inequality singa sigidi line singa sigi mathak thangmani y axis kina rightward x axis kina upward adu sidi unbounded ni with APD hariba point sina maru oiba corner point sing ore point singa adu a gina 3 0 ni p gina 3 by 2 half ni d gina 0 2 ni. At A, the value of above Z is 3 into 3 plus 5 into 0, 9. At P, the value of Z is 7. At D, the value of Z is 10. Value ahum si point ahum sigi value ahum phangi Z ki sida minimize quite pick paragraph 7. Thus minimize Z is 7 when X is 3 by 2 and Y is half. Machine the market solution. Question number 5. Maximize z equal to this subject to this value sini. The graphs of the equations corresponding equation ire 10 yelaga intercept formula thame ani subugi su 15 ga manare 15 yelaga si phange. Mathangidi x equal to 0 and y equal to 0 are the lines a b c d y axis and x axis respectively as in this picture. The feasible region is the shaded region OCPB with vertices origin gidi 0 0 C gidi 5 0 P gidi line anisibu represent over equation anisi solve toraga phangakoni 4 3 aduga B gidi 0 5 graph yakuda thengna khre. At O the value of above Z is 0, at C the value of Z is 15, at P the value of Z is 18, at B the value of Z is 10. Value point mari sigi value mari phange. Minimize maximize harabani value mari sigi khwaidagi chawbudi 18 ni. Thus maximize Z is 18 when X is 4 and Y is 3. Question number 6. Minimize this subject to this so that the minimum of Z occurs at more than 2 points. Wahang asida minimum of Z si mafam anidagi henna laigani ulam mo haibani. Let us solve the graphs of the equations in equations sing asigi corresponding equation laide intercept formula thame aduga makoi sing asigi graph ye matang sina abcd y axis and x axis thole maming sing. The feasible region is the shaded region X, C, B, Y. C की point asidi C 60 lere B gina 0 0 3 lere adu HC the value of Z is mata kishta chilasi 6 plus 2 into 0 is 6 ni at B Z की value is 6 phange point ani C की value animak chap manare. Thus, minimum Z is 6 either at x equal to 6 and y equal to 0 or at x equal to 0 and y equal to 3. Hence, minimum of Z is 6 at all points on the line segment joining 6 0 and 0 3. Point anisi samjinable lai esteleba point khudingmaki Z ki value the 6 phangani. Aduna a point anidagi henna Z ki minimum value piba ngamba point anidi henna lai haibadu utle mathang su hojiki value ani laibaduni utkadori si minimize and maximize Z haibani graph exe in equation singa sige de corresponding equation intercept form thame ani subagi su 16 yalaga ahum subagi di yenangai letre sumna thame line singa si ahan bana ab ani cd o f y axis x axis respectively ahan badudi ab kawrabanina A ga B ga sige line asibuni mark equation di x plus twice y equal to 12 ahang jaga side ire aduga mathangi di x plus y equal to 16 ni machine cd tole cd asi tole mahaki graph ile ahang jaga side mark equation adu isele mathangi di x equal to twice y haraga di origin power ef haina thonba sige line asine o ga f ko samjana basini mathangidi x equal to 0 di y axis ni y equal to 0 di x axis ni hariba equal line mari si 1 2 3 4 5 line manga si single maki feasible reason gi damakta di in equation singa sigidi mataki ab asigidi downward sini aduga cd asigidi upward sini line asigidi downward sini y axis kana upward x axis kana upward haraga di sig reason kama shaded reason sina feasible reason. The feasible reason is the shaded reason karamba APQC with vertices A ki coordinate 120 0 ni P gi solve toraga phange 60 30 Q gi solve toraga phange 40 20 C gi graph yakuta thena khare 60 0 hariba point singa sida Z ki value puto imata 1 by 1 asumna puto e value point mari C gi value mari phange khwaidagi bigpa khwaidagi chawba haibani achawbadadi ani phange. Thus minimum Z is 300 when x equal to 60 and y equal to 0 and maximum Z is 600 when x is 120 and y is 0 or when x is 60 and y is 30 magri point ani lere. Hence maximum Z equal to 600 occurs at all points on the line segment AP is the labor point khuding makna Z ki value says 600 loina pigani masigi koina khangle maximum Z asidi point anidagi henna laigani haibadu ule. Question number 8. Graph EXE precision minimize and maximize 7 graph sing yekani corresponding equation sing asigi graph yekani A B C D E F asumna koina yekle yeklaba matung dagidi wa koina the feasible region is the shaded region B Q P F with vertices B gidi 50 0 50 Q with solve toraga phangi 20 40 P gisu solve toraga phangi 50 100 F with 0 to 200 ne hariba pointing asida 8b the z ki value puto a q the z ki value puto a p the z ki value puto a f the z ki value puto a minimum khwaidi ki pick the 100 no ore maximum adu the 400 no ore bounded ore bani thus minimum z is 100 when x is 0 and y equal to 50 or x is 20 y is 40 at all points on bq the point khuding makna minimum value of z pire. Again, maximum of z is 400 when x equal to 0 and y equal to 200. Hence solve. Question number 9. Let us draw the graph of the corresponding equations. The graph A, B, C, D, E, F, x-axis yekle. Graph as yekle. The feasible region is the shaded region EPQ. Feasible region to EPQ hariba sig region asina feasible region. With vertices E that is 60 ni, P that is 41 ni, Q that is 32 ni. Point single sida 8 E the Z ki value minus 6, 8 P the Z ki value minus 2, 8 Q the Z ki value 1. Maximize haibani. Maximize the 1 tare. The feasible region is unbounded. So Z equal to 1 may or may not be maximum value. Haibadi feasible regions unbounded oiragadi maximize maximum amasu minimum puthokpa yadri. So z equal to 1 khwaidi chawba value 1 se may or may not be maximum value oramba yai oramba yai further koi makha tana test over tari. For this we draw the graph of inequality minus x plus twice y greater than 1 and the half plane open half plane has points in common with the feasible region. Asumna piramiba 1 asid inequality asigi half plane ado magi mathak thangba saruk asini feasible region asiga common region laire hence z has no maximum value. Common region lairabadi maximum value lairoi common region laitrabadi 1 asina maximum value oigada. Question number 10. Subject to this, the graphs of the equations ahan bagina silare ani su bagina silare matang x equal to 0 y equal to 0 are the lines sing asi singe ma ki line ani parallel over line ani phange ahan bagina ab common cd y axis x axis respectively. The feasible region lies in the first quadrant. Feasible region is the first quadrant laire. The feasible region is not common oidre tongan taba separately label common region ani phange. Thus, there is no maximum value of z. Z ki maximum value litre mafam asidari. Extra questions. Thank you for watching video.